Welcome back. This is Professor Paul Gruhn from Manchester Community College. We are in class CS230, Database for Web Applications. And we've been using Murach's book, MySQL. And today we're in Chapter 10. And as I've mentioned already earlier, is that typically Chapter 10 information is actually done and in the earlier chapters where we design the database and then get data into it and then build it. And what this book has done is that let's take a look at a pre-existing database and start learning how to manipulate and looking at the data. And by working the data like that, what's actually happened is we're getting a sense of the design already. And so now the design work shouldn't be so hard for us. So what we don't have any SQL statements to issue in this book and in this chapter, and we're really going to focus on the PowerPoint slides that you can download from Blackboard, and just kind of high level look at the elements, and we're going to use the AP database as a reference point. Excuse me, still fighting something. I also want you to be thinking about your final project now. By now, you should have an idea of what is the high-level topic, what's the database you want to create. So, for instance, for me, I think I'd like to create a Corvette-based database. And so what information can I pull together in a Corvette database that would be helpful? And more particular, I'm going to focus on one very particular model. I want to focus on the 1996 Collector's Edition LT4, because I know there's less than 2,000 of those. I happen to own one, and I want to get as much information about that car as possible. But I'll probably do it in the higher context of all of Corvettes, because Corvette, there's a lot of information about them out there, and I could start building some basic Corvette information. So let's see how that goes, and I want you to be thinking about your final project. Also, if you're going to be taking CST258, you'll be able to use the database you create in this final project as the starting point for your CST258 website. So be thinking about what type of database that you would want to have on the web. Also, if you're going to take CST258, you will need a website of your own. So I suggest, and a domain name. I suggest looking at GoDaddy, HostGator, there's a lot of different. Just find, say, cheap web hosting, and find a web host that's probably less than $10 a month, and probably you can get them for $7 a month. The key thing is make sure it has PHP, MySQL, and cPanel. And when you have those things in a database, in a website, a web hosting service, you'll be able to do everything you need for CST258. There are some free ones out there. Some of them are a little funky in how they work, but I think Wix is another place you can get a website at with PHP and MySQL. So be looking for that. We'll be talking more about that later. Okay, so let's dig into Chapter 10. We'll be at page 277. Okay, I'm using the PowerPoint slides that are provided by the book, and basically they go through the book, and if you look at the video, you'll see the PowerPoints, and you can page around with the book as well, and kind of get through this and start to understand it. How to design a database. So first of all, the database is the high-level grouping of information. The goal of this chapter is we're going to learn about specifications for a database. Okay, the whole bigger picture, the tables that live within the database, the columns which live within a table, the keys, which are the primary IDs, and how they relate, how a key is the identifier to another record and those relationships, and indexes. Indexes help those relationships, a key finding another piece of information in another table quickly. Give the tables an unnormalized database and a normalized structure to the third normal form. We'll talk about normalizing data and unnormalizing it. A relational database by nature is unnormalized. And then at the very end, we'll talk about the SQL Workbench and working with a identity relationship model. Also, we'll talk about when we index a column, what are the three criteria? How do we know we need to index that column? We'll describe referential integrity, explain how to use MySQL to use declarative referential integrity to prevent deletion, insertion, and update. In other words, by having good declarative referential integrity set up in your database, you won't mess up and delete stuff by mistake. And how to normalize the database to a third normal form, how that affects performance. Okay, now let's talk about data. We're here on page 279. And in the real world, when we think about a real world system, we can think about people, facilities, documents, and other stuff. So for instance, if I was to be working on a Corvette database, as I mentioned, I could be thinking about the models. There's C1, C2, C3, C4, all the way up to C7. I could think about types. There's convertible and coupes. I can think about motors and engines. I can think about a lot of different things. There's even paint codes. There's a lot of different things that make up all the area of a Corvette. And so I can think about the data as just real stuff that I want. You know, for instance, I could do a home inventory and I could look at my house and I could say, I have a house. In my house I have rooms. In my rooms I have different types of things. I have couches, I have chairs, I have tables, I have silverware, I have pots and pans, television sets. So there is the real world things that I want to maintain in a database. Those will translate to an overall database system into tables and ultimately into columns and rows. So when you're designing a database, the first thing you need to do is identify the elements. What's the stuff? Divide the elements into groups, useful components, identify the tables that would be for those components, and then figure out how you need to access the data, and that will get you your primary and foreign keys. And review whether the data structure is normalized or not. And you're going to identify the actual indexes based upon the primary and foreign keys. Okay, so now let's take a look at an invoice. And now you're very familiar with the invoice form, the invoice database that we have, the AP database that's in the that we've been working with so far. So I'm actually going to pull that up, and we can see the relationships here. And let's pop this on top. This is going to flip back and forth on us. So within the AP database here, we see, so here's an invoice, and we see a lot of different types of information. So right up the top, we see custom contraptions, controversies, and confabulations, and where they're located, and their address, their phone number, fax number, and even their website. This information here, Acme Fabrication is the company who is doing the business, creating the invoice, and they're billing a vendor. They're billing a company here. So this information right here is in the header of the invoice, but basically it's all about the vendor. So if we take a look at our vendors table, and if we go describe vendors, we see we have an ID, we have a name, an address, a city, state, zip, a phone, and contact information. We even, for this vendor, we have a terms ID and an account number. So interesting that what happens is, notice here in the invoice record, we have terms net 30. So how did the net 30, how do we determine what the terms are for this invoice for this vendor? Well, what happens is there's a terms ID, and that refers to the terms table. So if we describe terms, we see that we have a terms ID, a description, and a due date. And if we actually select star from terms, we see that we have terms ID, a description, and the number of days that are actually due for those for those invoices with people with that terms. So now if we go back and we select star from vendors, what we see is this vendor has a default terms code. That terms code will default and when we pull up a new invoice, it'll say, which vendor are you and what's your default terms code? Now what's also interesting is in the invoices table, they actually have a terms ID that a vendor, that we would be allowed to change the terms on any particular invoices. But you can start to see the relationships that we need a vendor table and we need a terms table. And we have an overall invoice table. The invoice table is all of this stuff. So if I was to describe invoices, invoice ID, vendor ID, invoice number, invoice date, invoice total. Take a look here. We have invoice number, invoice date, invoice total. We have a terms ID. And we have the payment due date. I don't know, is it listed here anywhere? Not in this case. That would be behind the scenes. We have an invoice date right there. So what happens is the invoices table is the center point of this that then ties to a lot of other tables to gather and gain information about that is needed for this invoice. So when we go select star from invoices, we see an invoice ID, a vendor ID, which relates to the vendors table, an invoice number, and that invoice number can be anything, the invoice date, the total, the payments, the terms ID, the due date, based upon the calculation of how many days for that person's terms, and when they've made payments. Also, we see an invoice has line information in it. The line information actually is from right here, the invoice line items. So if we describe invoice line items, we see we need to know what invoice it comes from, the invoice sequence, which number, which line 1, line 2, line 3, what's the account number related back, and then the item amount and the item description. What I don't see is quantity. So that's interesting. I don't see quantity on that, which I would surprise. So if we go select star from invoice line items, we see that we have the invoice IDs, the account number, the line item amount, and the line item description. And so we see the information and it relates back. So right here, let's try to find something that is more line item amount, invoice ID, Hang on a second. Okay, so I found the missing relationships. It was dug in a little deep. I don't know if I would have designed it this way, but that's okay. We all do things differently. But these line items here are actually pulled from the orders table, and the orders table is in the order entry module. So if we do a use OM, we describe the order details. We see we have an order ID and an item ID. This item ID relates to the items table in the order entry model, so we can find out what it is, and then the quantity relates to how many were ordered. So the relationships are built there, and when we select all of this, what we see here is we see a multiple. Here's an order number 264, item ID 4, 7, and 8, and how many of those that you ordered. So these tables are really relating together in a lot of different ways. Let's move. Also, we see down at the bottom that there's a salesperson information and accounts receivable contact. So there's a lot of pieces of information that make up an invoice. The data elements on the invoice document. So here's it listing it out. Vendor name, vendor address, all the invoice information, item information, vendor sales information, and the invoice total. So by looking at the data that you're interested in putting into a database, you kind of look at it at a business, at a functional, at a real world level, and then ultimately you have to break it down into this piece of information, this piece of information, and this piece of information. And then what now we start to see, and we're looking up on page 283, the vendor sales contact. And the vendor sales contact name can actually have two pieces, a first name and a last name. You'll find that in databases with names and stuff, having first, middle, and last is very helpful. Putting it all in one can be frustrating, especially for last names and lookups and things like that. The vendor address is coming from the vendor file, and on that invoice, on this invoice, we see this whole address line right here, and this line of telephone numbers. That information is coming from a street field, a city, state, and zip field. So separate fields were then displayed together to put into one column of information. Possible tables and columns for an AP system. So now what we have is some information, and it looks like we're crossing out some information that we might not want. Data elements that were previously identified but aren't needed are crossed out. So for some reason you might say, you know, I have this but I don't need it. Data elements that were added were displayed as italics. Data elements that are related to two or more entities are followed by an asterisk. So what happens here is, notice here that there's the stars, the asterisks. These are saying I need this piece of information because it's going to relate to information in another table. So what you would do is list out all the pieces of information you think you need, decide, do I really want it or not, and then you start to think about the relationships. If I know I'm going to have a terms table and a terms ID, and then you star it, and that helps you say, okay, I know I'm going to have these relationships being built. And now from here we see this diagram being displayed, where what we have is the vendor table, the invoices table, and the invoice line items table. And you can hear my puppy in the background. Okay, so when you go into the modeler in Workbench, you'll create a new database model, and then you'll basically create tables for the information that you'll need, and then you'll start putting the column information that you'll want. And you'll also define what are going to be your key fields. So for instance, a key field here, here's the vendor ID, it's highlighted, it's bolded, the invoice ID, and the key field here on invoice line items is a combination of the invoice ID and the invoice sequence, and the joining of two columns into the using of two columns actually makes the primary key. Primary keys are always unique. You can't have a primary key with being equal to the same in another record. Okay, as we've talked about, we have a vendors table, an invoices table, and an invoice line items table. And what happens is we have relationships, and they are dependent upon each other. Sometimes what we will have is a many-to-many relationship. We can have an employee ID, so there's only one employee, first name, last name, and that employee ID is linked to a committee ID, so in the memberships table. So an employee can be a member of a committee, but that committee, so we have one committee ID and one committee name. You have the window committee, the floor committee, who knows, whatever, different committees. That can be, so we have different committees, the red committee, blue committee, green committee, and we have employees, Paul, George, John, and Ringo, and they can actually be in different, more than one, they could be a member of more than one committee. So what you would have is, you would have Paul ID in 2 or 3 records with Paul, with those 2 or 3 committees in there. So this is a one-to-many, where one ID is in this table where many IDs could be, and one committee, but that memberships many employees. So many employees, one employee can be a member of many committees, and many committees might include members, employees of many of I'm not saying that right. The point is, you can be in more than one club, and there's lots of clubs out there. So this is a many-to-many relationship, and the uniqueness of but you can only have one employee ID and one committee ID on each row of information. So you would not join the employee and the committee in this memberships table more than once. Now you have a one-to-one relationship, where here we have an employees table and we have an employee photos table. And the reason we probably have a separate employee photo table is because the photo images are large, take up a lot of space, and we might not need them all the time. So having a separate photo table makes a lot of sense with that one employee ID relating to the one employee photo. And yes, you can store photos in your MySQL database. So think about your final project. It would be cool to have a photo table related to something in your project. Maybe like your home inventory, you'd want to take a picture of the thing, and being able to display that on your website. Okay, so we've talked about these relationships of one table to another, and the primary key is the primary lookup key in one table, and the foreign key is the sub key that relates to it. The problem can be if we break one side or another of that relationship, our database will start to fail, and we won't be able to get our data the way we need. So for instance, deleting a row from the primary key table, if the foreign key table contains one or more rows related to it. So say if you have the invoice line item table, but you delete the invoice table, a row, so invoice number 100 in the invoice table has 4 or 5 rows in the invoice line item table. So now we have this invoice line item table. If we delete invoice number 100 in the invoice table, there's no relationship to that foreign key in the invoice line item table because it's gone. Inserting a row in the foreign key table. So now if a foreign key doesn't have a matching primary key value, so by adding a new row in the invoice line item table, but it doesn't have an invoice table to match it, it's like you just deleted it or it just doesn't exist. So now your relationship is broken. Updating the value of a foreign key. So remember, we can change data. Now if in the foreign key we have the invoice line items at 100, and we have line 1, line 2, line 3, but we change that to invoice number 7,000, and we have no 7,000 in the invoice table, we've broken that relationship. And if we update the primary key in the invoice, change 100 in the invoice to another number, 8,453, we've broken that relationship. So whenever we do database work, when we do updates, when we do inserts, when we do deletes, we have to know and understand these relationships, and we have to do it across all of the primary tables and the foreign tables so that the data is accurate. So it's the integrity of the data, and we can do things very, very easily to mess that up. So a lot of us grew up with Excel, or even simpler, a piece of paper with lines on it, and we would draw columns of information. And we might be writing some information down, storing some information, and we would end up duplicating the information and writing it in such a way that it really became unmanageable or redundant, but sometimes it's the easiest thing to do. Here's two examples where that the table contains repeating columns. So we have Cantor's Publishing, we know the invoice, and we have item description 1, 2, and 3. But what happens if there's items descriptions 4, 5, 6, and 7? We have to keep adding columns. Now, the way to get around that is we then have a table that contains redundant data where Cantor's Publishing and the invoice number are listed on different rows, but we now have the item description nicely and uniquely in each separate row. So what you can see is both models, while they kind of work, they don't work. And this is where we then have this relationship of the invoices to the line items, to the vendors, the terms to the vendors and to the invoices, and the general account terms goes to both the line item and the vendor as well. So this shows you how you can store the data more efficiently and not have to have the vendor name repeated tons of times, because all you have is the vendor ID. You don't have to have the terms description, or you don't have to repeat the item description over and over again. So the third normal form, or this relational database form, is the appropriate way to go. And quite honestly, it gives us database programmers a job. Okay, when do you create an index on a field? On page 293, it lists out the three types to do that. When a column is used frequently in search conditions or joins, it basically makes it go faster. An index will get your results right to the place. When a column contains a large number of distinct values, so if you have a lot of data and a lot of the data is unique in a column, so it helps get that information very quickly. And when the column is updated frequently, so if you're changing information and data in a column, you might want to index it so you can get to it quickly. So those are some rules, but primarily is if I have a main table and I need to relate to a subtable, a child table, an index on those keys is usually working. But if I know I'm going to be looking up my customers by last name, first name, I'd probably create an index called last name, first name, because that way I can type in the last name, type in the first name, and it will hopefully get to those records very quickly. And think about it, sometimes we have tables with millions and millions of records. Okay, on page 304, it starts introducing you to the identity modeling tool. So we go into MySQL Workbench, and instead of going into MySQL development, we can open up existing models. I happen to have a couple there, but I'm going to create a new entity relationship model, and I have a workbench. Hang on a second. And what I want to do is I want to add a diagram. I'm going to click, and now I'm in the workplace for this. I'm in the place for the diagram. Now notice that in the catalog tree, there's this information here about the diagram. It relates to the things we'll put on. Down here, right in the middle, is place a new table. So if we click there, we have a table. And notice table 1 appeared. So if you go to page 309, you should be able to start to duplicate that table. And if you click on the table down here at table name, we can type vendors and hit enter. Now we see the vendor is listed as a table. And now we have a invoices table. So let's click a new table. Whoops, I clicked the wrong thing. I didn't have a table. Delete that. Right click, delete. That was text. I want a table right here. Click on it. Double click on it. Come on. There we go. Invoices. And then invoice line items. We need another table. So what I like to do is double click on this down at the bottom. Invoice line items. And terms and general ledger accounts. Terms and general and I see that I was camel casing these. It's probably better just to do all of these in lowercase. Invoice. Okay, so what I'm going to do is I'm only going to show you 2 that are and then you can play and figure out and do the rest of these. Let's take the terms table. The terms table has a terms ID, a terms description, and a due date terms. So if we click on there, and what we can have here is we can add columns. So the column name, terms ID. And the terms ID, we're going to make it integer. It's going to be a primary key, and it's going to be not null. So we're checking that off. Terms description. Description. That's going to be a varchar, and we don't need to look it up. We don't need, but it should be not null. And then we have terms due days. Term due terms due days, and that's going to be a integer. Int 2, and that's going to also be not null as well. So we need to have data in all of those. So now, if I open up this table, let's see, Control S. Oops. So if I want to save this model, and I'm going to put it on my desktop, AP database. Okay, silly me, I was working on the line. I'm wondering, why isn't my terms table working? I was working on the line items table. So what I'm going to do is I'm just going to change this to terms, and then I'll change this one to invoice line items. So I was working on the wrong ones, but I was going, why wasn't stuff getting added? And we see it there. Now I'm going to click on my invoices table, and I want an invoice ID, and that's going to be integer, primary key, unique. And then I want a terms ID, and that's going to be an integer as well. Oh, see, I was looking for that there. So let's go back to this terms table, by the way, and change this due date here. I didn't see the int all the way up there. So now what we can do is this terms ID here, we want to relate this to the terms table here. Okay, so now what we need to do is set up the key relationships between this terms ID and as a foreign key in the invoices table to the terms ID primary key in the terms table. And if you click down here on foreign keys, you can call this key anything, but we can, I'm just going to, I want to call this key terms ID, and it's going to reference the table in the terms, and in the terms table, which of the columns from the invoice table do I want to use the terms ID? And now you can see the relationship, the line is drawn. So what I'd like you to do is, by looking at page 309, get all of the columns in, get all of the data types set, and then see if you can build your relationships. And if you play with that for about 20 minutes or so, you'll start to see how the tool works. And then on page 311, there are 3 different identity diagrams that you need to draw for your homework assignment. So hope this has helped, and we'll move on to chapter 11, where we actually get to create these tables and this data that we've designed.